We're going to start with an opening from Hamid, who's Senior AI Researcher for Shell, who's just going to introduce what he's doing from vision to autonomy at Shell. And then from that, we're just going to go straight into the roundtables. And that's going to be in this room. And then people can then just sit where they want to do and contribute as they are. So big round of applause, please, for Hamid Fehri. Thank you. You should have the clip. Yeah, you have the clip up.
Okay. Hello, everyone. Thanks, Adam, for the introduction. Do I have my slides? Yeah, great. Okay. Good morning, Aberdeen. Yesterday, I wasn't here, but I suppose this room debated whether AI is ready for oil and gas or not. Today, I'm here to hopefully show that it is ready. At least in Shell, it already is. I'm Hamid Fehri, Senior AI Researcher at Shell. Today, I'm going to go from computer vision that are enabling computers to see to agentic AI that is enabling systems that can act. Most of what I'm going to show today is already in production, so real problems in real assets and real solutions and real impacts. The title I've chosen, From Vision to Autonomy, is actually pointing to two meanings. Literally, it means from the machine vision or computer vision, which is teaching computers to see industrial assets, and progress to agentic AI, systems that can diagnose, detect, and act responsibly. Metaphorically, however, is referring to the journey entire oil and gas industry is in, which is like what AI can do to how it can be deployed at scale in the industry. So today, I'm going to go through some use cases and hopefully the message come across as I intend. Just a forward-looking statement as standard cautionary disclosures. So next few minutes, I'm going to discuss about 3 points. First is C, so machines that can perceive the physical reality, is integration, like 3D reality and visual search. Second is going to be ACT, so agentic AI that not just observes, but it operates. It manages its own models, triages networks, and even captures the unknown. And finally, trust, which is a theme here, and that's responsible AI making this happen and making this happen at scale. So because of that, we want governed AI and explainability. Before AI can act, it needs to see. And in Shell, we make this happen by turning every camera, every drone, and every laser scan into an inspector that never tires, never blinks, and never makes the same mistake twice. Imagine a Shell asset or any other asset, a platform, that has kilometers of pipelines, thousands of pieces of equipment. All of these need inspection. For that to happen manually, engineers need to go and physically attend the asset. They need to navigate to confined spaces to find the issues and to do the inspections. This puts them to safety risks as long as taking the procedure is so long and inefficient. Using AI here would mean that we fly drones that capture hundreds of thousands of images from an asset. Then, using our ML-trained models, we detect anomalies, including corrosion or any sort of defined anomalies. Once that is done, we'll geolocalize that in a 3D model, and this is automatically sent to IMS. This helps a lot in the efficiency, making the whole procedure at least 2 times faster. Because of the drone coverage, instead of humans, it can cover quite a larger area, so increase the coverage. And also it's consistent, because AI is different to 2 human inspectors that might have different opinions about the same phenomena. And As a result, it also exposes less risk to our human operators. So that's how AI can be used efficiently for inspection. And once we deployed this in one of the assets, we received interest from the other ones across the shell. Looking into the ecosystem, this involves Air Compare, which looks at point clouds that are gathered through images over time and compares them. So you can have an understanding of evolution of a corrosion. It gives you a sense of predictive maintenance, not only a reactive inspection. We have CAN-CUI, which is corrosion under insulation. This is a hidden hazard. It can happen without people notifying it, people noticing it. Sorry. And we do this through combining machine vision, NLP, and AI. So we sort of understand it when it's happening, even though it's under layers. Flange face inspection, this is very important because there are turnarounds that whenever they take days, it costs millions to the asset. And it actually is very important because every flange needs to be inspected at least every year, for example. We help this accelerated by using AI. Instead of the human operators looking at them, we use AI to compare this over time and compare the images over time and understand if there is any issue with the flange, for example. We use this for subsea, so extended the same procedure to under the sea through ROV footage, and also for electrical cable inspections and theft detection on an extreme scenario where tampering in cases could be identified through drone images. I also want to touch on the point of 3D point cloud models that might be available in many assets, but in many cases, the issue we have is that these models are not up to date. As a result, engineers prefer to just go back to P&ID diagrams, which can be from decades ago, not necessarily the updated 3D models. But the problem with this is that maintaining such models is not easy and is not cheap. In order to have that in place, we have an automated pipeline where periodically takes images. Once the images are taken, they are localized again through pose estimation. Pose estimation helps understanding from which location and from which angle each image has been taken, so that you can make a 3D model of the surface of the asset. And then once that is done, we use a segmentation model to identify each object in the 3D model. After this step, the segmentation that has the equipment identified in it is compared to the existing models and also CAD models. Wherever there is a change, then the engineers are notified. So instead of the engineer or operator looking at every piece of the asset, they just and simply look at the changes. And if that change is valid or is notifying a risk, then they take it further. I also want to note here the responsible AI bit, because not all of this procedure is autonomous. We have the engineer at the critical point of decision making and also at assessing if it's performing well or not. Also, another asset that is most of the time hugely underutilized in oil and gas especially is visual data assets. There are images that have been taken over time. It can be several years, or even up to 2 decades, that are there from CCTV, from drones, from even engineers' tablets that take images, but they've just been uploaded somewhere. In order to use that data, one can come up with a system that uses actually a visual search that works with natural language. So for example, with this system, you can ask AI to look for a specific type of electrical switch in a platform and then you can describe it because it understands natural language, and then it searches within the images as well. Imagine you want to make a new use case, and then you have very limited data for training your models. This allows you, also with HPC enabled in it, allows you to look at the existing data that previously has been collected, but not necessarily been considered for this reason, this new reason, or this new use case, and it can help a lot in training new models or defining new use cases. That's actually how we can convert data landfills into data assets. But the real leap here is when AI is not just reading or making reports, but rather is taking decisions. I've got some examples of that to give an insight on this. Agentic AI models can give you the opportunity to maintain AI models by AI. In any company or any asset where they are using several deep learning models, for example, there is a need to maintain several, or we've got hundreds of deep learning models that get out of date. The reason for them becoming obsolete is the new expansions, new equipment installations, or simply changing some parameters like seasonal changes. And as a result, the models get outdated. If you want to maintain these models manually through data scientists' efforts, it's going to take long, and they need to spend time, instead of thinking on new projects, developing new things, maintain the same thing. So what agentic AI can do here is that through multiple agents collaborations, agents instead of humans, multiple of them, when they work together, they can maintain these models. What they do in brief is that they consistently look at the performance of models, multiple models at the same time, and if the performance is lower than a threshold, then they trigger a retraining. Retraining starts from collecting all of the new data, making a new data set, doing the annotation, performing the retraining, and once the model is ready for deployment, they send it for deployment. But again, here we have the human switch in the end, that before deployment, it oversees all of the performance, and if all of it makes sense, it allows, that person allows for the integration or deployment. I have an example of how agentic AI here can detect network problems as a use case where, instead of network engineers who are consistently looking at the performance or issues, could do the root cause analysis and find the problems that were causing firewalls making failures, where this can not only do the root cause analysis, but also can make recommendations on what would be the remediation steps. Also, briefly pointing to the fact that so far we've been dealing with the abnormalities that were unknown. So we had defined abnormalities. But we can use machine learning and AI to find the unknown. So that if we just know what is the normal, then how can we point out or raise when something is happening abnormally? For this, instead of training our models on the abnormal cases, we very well train the model on the normal case. So we help it understand the normal distribution. So whenever something out of that distribution comes by, it can raise it. But sometimes you have very limited data, and that is when you use generative AI to create a diversity in your normal distribution, if that makes sense. And then once that is in place, it can nominate abnormal cases, and finally, the human operator would decide if this abnormal is actually an anomaly or is just an outlier normal. I'm going to skip this one, but if I want you to have three takeaways from today, this morning's talk, it's going to be all of what I showed today briefly was all in production. So real problems that were approached. vision becomes autonomy. So from the ability that AI provides us to gather and collect data and do pattern recognition, to making decision, this gives a big spectrum of what AI can do. And all of this is obviously just possible and extendable through having responsible AI in place. If you don't have responsible AI in place, it's not easy to extend, it's not possible to extend, and you lose governance and traceability. So let's build autonomous and responsible energy operations together. Thank you, everyone.